Hey guys, so we're going to get into the trig portion of the geometry class right now. This section breaks down the basic three trig ratios, okay? They're called sine, cosine, and tangent. Basically, they're functions of that compare sides of a right triangle through ratios, okay? So you may or may not have heard something called SOHCAHTOA before. It's an acronym that we use to help us remember these ratios between the sine, cosine, and tangent and the other sides of the right triangle. So you have to start with the right triangle. Okay, so we've got one right here. Let's call it triangle ABC. Okay, and from triangle ABC here, right, I'm going to name the sides across from it with lowercase letters of the same kind. Okay. Now, basically, what this does, right, you can find the trig ratios from either of the acute angles of a right triangle, but you can never use the right angle. So you're never going to try to find like the sine of 90 or the cosine of 90 or tangent 90. You're never going to use that ever. Okay. So we could do it with A or with B. What I've got set up here is A, first of all, and then we'll do B as well. All right, so sine, use the acronym SO. It's sine of whatever angle it is. It equals the opposite side over the hypotenuse, okay? So sine equals opposite over hypotenuse. You want to write that down for sure, okay? So if we're going to use angle A here, the sine of angle A is going to be the opposite side, okay, which is going to be A over here over the hypotenuse. The hypotenuse obviously doesn't change, okay? So there's three sides based on what angle you're using. So if we're working with angle A here, right, A is going to be, side A is going to be the opposite side, side B is going to be the adjacent side, and side C is obviously the hypotenuse. Okay, so these ratios, the sine is going to be opposite over hypotenuse, which is just A over C. Okay, the adjacent, or the cosine is adjacent over hypotenuse, which is just B over C. And TOA, tangent, means opposite over adjacent, which for angle A, it's going to be A over B. Okay, but we could do the same thing from angle B. All right, so if we want to do the same thing from angle B, the hypotenuse isn't going to change. The hypotenuse is still going to be C, but what is going to change is the adjacent and the opposite side. Because if you look at this, the side that's opposite of angle B is across the triangle here, over here, side B, and the adjacent one, the one touching it, is over here at A. So in blue, I'm going to write down the relationship between these sides and angle B. Okay. So we could write these ratios once again for angle B. So if we had sine of B, it's going to be opposite over hypotenuse, which is going to be B over C. Okay, the cosine of B is adjacent over hypotenuse, which is going to be A over C. And the tangent of B is going to be the opposite over the adjacent, so B over A. Okay, I know it seems really tricky to get started here, but once you see numbers and all that, I think it makes a little more sense. Let's do one quick example before we go to the real examples. Right here with this triangle, we're just going to find the sine, cosine, tangent of both A and B. All right, C is our right angle, so we're not going to use that one. But we can find the sine of A, cosine of A, tangent of A, the sine of B, cosine of B, and tangent of B. All right, so in order to find the sine of A, remember that the sine of A is opposite over hypotenuse, so the opposite side is going to be this 48, and the hypotenuse is going to be 50, so we're just going to have 48 over 50. Okay, and then we can break that down or reduce it, and we're going to get 24 over 25. Okay, the cosine of A, remember we're going from angle A up here. Cosine is going to be adjacent over hypotenuse. The adjacent side, the side touching it, is 14. Hypotenuse is 50. So that'll be 7 over 25. And tangent of A is opposite over adjacent, which is going to mean 48 is opposite, 14 is adjacent. So 48 over 14, which is 24 over 7. Okay, we can do the same thing for B. So if we're working with angle B over here, the sine is going to be opposite. Okay, opposite is 14 over hypotenuse. So 14 over 50, which reduced is 7 over 25. Okay, the cosine of B is going to be the adjacent over hypotenuse, which is 48 over 50. 24 over 25. And the tangent is opposite over adjacent, which is 14 over 48. Reduces to 7 over 24. Okay? So that's what we're going to be doing in this chapter. Let's go to the examples. Alright, so we're going to find the three trig ratios for 1 and 2 here. Okay, very simply of these. Alright, so we're going to work with sine of k, cosine of k, tangent of k, and we're also going to do it with L. Cosine L, tangent L. Now, this one is a 45, 45, 90 triangle, so first we need to figure out these side lengths. Now remember, the ratios here, we've got the hypotenuse is 6. Remember, the hypotenuse of a 45, 45, 90 triangle is like x root 2. Okay, so in order to get each leg, we have to divide 6 by square root of 2. So 6 over square root of 2 has to be rationalized. So it is 3 root 2, or 6 root 2 over 2, which reduces this 3 root 2. So 3 root 2 goes here, and 3 root 2 goes here. Alright, now, with that, we can write our ratios, okay? So the sine of k, alright, if we're working with k first, I'll do this one in red. Alright, if we're working with k, that means we're going to have opposites over here, adjacent is right here, hypotenuse is always across from the right angle. Okay, so we're just going to fill in everything we got. So sine of k is going to be 3 root 2 over 6, which is just root 2 over 2. Okay, cosine of k is once again going to be 3 root 2 over 6, which is root 2 over 2. And tangent of k is going to be 3 root 2 over 3 root 2. Anything divided by itself is 1. So 3 root 2 over 3 root 2. Okay, it's divided by itself perfectly, so it's going to be 1. And we can do the same ratios over here with L. Okay, angle L here. So that means that opposite's going to be here, adjacent's going to be here, and this is still the hypotenuse. Alright, so when you work this one out with the ratios, opposite over hypotenuse is going to be, once again, 3 root 2 over 6, which is going to be root 2 over 2. Cosine, once again, 3 root 2 over 6, which is root 2 over 2. And the tangent's going to be 3 root 2 over 3 root 2, which is 1. Alright, so you see that you get the exact same ratios for a 45, 45, 90 triangle. Now, number 2 here, the 30, 60, 90s. Okay, we have a 30, 60, 90 triangle. That's my 30 degree, right? We have our x. This y down here is going to be like our 2x, and the 12 is our x root 3, right? Because it's not hypotenuse, it's just a longer leg. So in order to get x, we have to divide 12 by square root of 3. So we'll need 12 over root 3, multiplied by root 3 over root 3, and we'll get 12 root 3 over 3, which reduces to 4 root 3. So x is 4 root 3, and 2x then is going to be 8 root 3. Let's erase this, give me some room, and we've got an 8 root 3 over here. Alright, so we've got our three sides of the triangle now. Now we can just set up our ratios. Sine of f, cosine f, tangent f, and sine of g, cosine of g, tangent g. Okay, it needs to be set up like this every time I ask for these ratios. So I'll do f in blue. Alright, now we can set from f, we know that the hypotenuse here is across from the right angle, it's right there. Opposite's going to be over here, across the triangle, and adjacent's going to be the 12. Okay, so if we want to do the sine of f is going to be opposite over hypotenuse, so it'll be 4 root 3 over 8 root 3. Okay, our root 3's are going to cancel each other out, which is left with 4 over 8, which reduces to 1/2. Okay, now cosine of f, it's going to be 12 over 8 root 3, adjacent over hypotenuse, so 12 over 8 root 3. Okay, all of you guys should practice how to rationalize this. We need to reduce that fraction, and reduce the fraction, and multiply by root 3 over root 3. And what you should get is root 3 over 2. Make sure that you're able to get that on your own. And the last one, the tangent of f, is going to be 4 root 3, opposite over adjacent, so 4 root 3 over 12, which is just going to be root 3 over 3. Okay? Now if we do the same thing over here with g, when you work through all these, why don't you guys do this on your own, since I've done a couple of these already. All right, you should get root 3 over 2 for the sine, 1/2 for the cosine, and root 3 for the tangent. All right, should look just like that. Now, a couple other different examples. For number 3 here, what we're going to be doing is we're going to solve for h and k. So we're going to use these trig ratios to actually set up an equation and solve for one of the lengths. All right. So we have a 51 degrees down here. This is obviously 90, and we have the 10. All right. We don't have x or h, but we can find both of them. So first you have to define from this angle that we know, from this 51 degrees, what each of these sides are with our trig ratios. Okay. So 10 is going to be the opposite side from 51. X is going to be adjacent, and h is the hypotenuse. Okay, so we can use the 51 and the 10 to solve for h. So I've been saying this whole time, right, sine of a or sine of f or whatever, sine of an angle. You have to have a specific angle, okay, for each of your trig ratios. So what we're going to use here is one thing that's really helpful for this is we can set up a way we can have the angle and one of the ratios, one of the numbers in the side ratio, to find another side measure of that ratio. Okay, so for example, we know that from this angle, opposite over hypotenuse is sine. Okay, so we can set up sine of 51 degrees, okay, equals the opposite, which is 10 over h. Right, now if you have a calculator, which you definitely need a calculator for this section, so make sure you bring one to class, you're able to calculate what h actually is. Okay, so we have to solve for h here. Basically the way you're going to solve for h is since h is in the denominator, you need to multiply it to get to the other side. So we're going to multiply both sides by h. Okay, so those will cancel out. You're left with h times sine of 51 equals 10. And now we can solve for h by dividing at both sides by sine of 51 degrees. Okay, so h will be by itself, and you type in your calculator 10 divided by sine 51 degrees, and you get 12.9. Okay, now that's h. Now once we have h, we can also do the same thing to get x, okay, but we're going to have a different trig ratio. Okay, so to get x, we're going to use opposite over adjacent. Okay, so that's going to be tangent of 51 equals 10 over x. Okay, multiply both sides by x, divide the tangent back over, and you're going to get x equals 10 over tangent of 51 degrees. Type that in your calculator, and the answer you're going to get is 8.1. Perfect. Now, I'm going to do one of these, I'm just going to do the setup for both of these, and then you guys can actually solve them. So you're measuring the height of a building. This is the word problem for this. You measure the height angle of elevation from a point on the ground to be 48 degrees. Right? You are 48 degrees. Okay? You're 100 feet away from the building. That's not in there. I'm just adding that in there. You want to find the height of the building. Okay? So if you want to find x there, the equation you're going to set up is going to be, right, what do we have here from 48 degrees? We've got the opposite and we've got the adjacent. We don't have the hypotenuse. Okay, so we're going to use the tangent function. So tangent of 48 equals x over 100. You can multiply both sides by 100 to get x by itself. So x is going to be 100 times the tangent of 48, which you can type in your calculator and get an answer. Now the last one here, number 5. All right, we've got a driveway rises 12 feet over a distance d at an angle of 3.5 degrees. So we got 3.5 here. There's our right angle. So it rises 12 feet. That means the elevation is 12 feet over a distance d. All right, we don't know what d is. So what do we have? We've got 3.5. We've got the opposite is 12, and the hypotenuse is d. We got to find that d. So remember, opposite over hypotenuse is sine. So sine of 3.5 degrees equals 12 over d. Multiply both sides by d, divide by sine of 3.5, and you're going to get sine equals, or d equals 12 over sine of 3.5 degrees, which you could type in your calculator and get an answer. Okay, good luck. See you in class.